Hello students, let us continue with exercise 8.1 of chapter 8 quadrilateral. This is on page number 146, question 9. We've been given that this huge quadrilateral ABCD is a parallelogram and BQ is equal to DP. So this is my given data. Besides that, ABCD is a parallelogram. So since ABCD is my parallelogram, I have the opposite sides equal and parallel. That means AB is equal to DC as well as parallel to it. Similarly, AD and BC are parallel and equal because the opposite sides of a parallelogram are equal and parallel. Now I need to prove 5 things. So do not get confused or do not panic that we have to prove too many things. This question appears to be very lengthy and difficult, but it is really very simple. So let's take a look. We need to prove that triangle APD is equal to triangle CQB. So if you notice triangle APD and CQB over here, let's draw our triangles for reference. I have APD and CQB. So first of all, these are the opposite sides of the parallelogram, they equal. In fact, I have marked these. We have PD is equal to BC, BQ, this is given, right? And also, if you notice, this angle is equal to this angle. That means angle ATP is equal to angle CBQ. Why? Because if you notice, AD and BC are parallel to each other and BD is my transversal. Therefore, angle ADB is equal to angle CBD, correct? But we have points Q and P on the line segment BD. So instead of saying ADB, I will say ADP, and instead of saying CBD, I will say CBQ. Therefore, the two triangles are going to be congruent by the side angle side test of congruence. So let's go ahead and prove this. So I will say proof. So first let's prove that ADP is equal to CBQ. AD is parallel to BC because they are the opposite sides of parallelogram, and BD is the transversal. Correct. Therefore, I have angle ADB is equal to angle CBD. Correct. So, why? Because alternate angle theorem. Therefore, I am going to say angle ADP is equal to angle CBQ. Correct? We will say P and Q lie on BD. Let's mark this as 1. And now let's go ahead and prove the two triangles congruent. So I'll say in triangle, so this is my first part, in triangle ADP and triangle CBQ, I have AD is equal to CB. Why? Because they are the opposite sides of parallelogram. We know that opposite sides of parallelogram are equal. Then I have these two angles over here, that is ADP is equal to angle CBQ, and I will say from 1. And again I have the given data that DP is equal to BQ. So DP is equal to BQ, this is given. Correct. Therefore, what can I say? That the two triangles are congruent by the SAS test of congruence. Therefore, triangle ADP is congruent to triangle CBQ SAS test. Let's mark this as statement number 2. So we have proved the first part, that is APD and CQB as triangles are congruent to each other. Now we need to prove that AP is equal to CQ. So if you notice, AP and CQ, they are lying in the same two congruent triangles. So for the second part, I am going to take reference of this equation. I will say triangle ADP is congruent to triangle CBQ. I will say from 2. Therefore, AP is equal to CQ. Why? Corresponding pair of congruent triangles, or CPCT. Let's mark this as 3. You never know what you might be needing as reference. Similarly, now first of all I will draw lines between the sections for better clarity. Let's move on to the third section. So we will take a look at the triangles over here itself. We need to prove that AQB and CPD are equal. So AQB and CPD. If you see, you have these two sides equal given. These two sides are equal. Why? Because the opposite sides of the parallelogram, the opposite sides of a parallelogram are parallel and equal. Also you have AB and CD parallel to each other, and BD is the transversal. Therefore this angle out here is equal to this angle out here. Therefore the two triangles are congruent to each other, again by the SAS test of congruence. So just like you have proved these two triangles congruent, ADP and CBQ, you can prove AQB and CPD congruent to each other. So let's go ahead and prove this. So for my third section, I will be needing this, I will need to prove that angle ABQ and ADP are equal to each other. So let's start with that. We have AB is parallel to CD, AB is parallel to CD. Why? Opposite sides of parallelogram. And what is my transversal? And BD is the transversal. So what can I say? That angle ABD is equal to angle ABD is equal to angle BDC or CDB, right? Alternate angle theorem. But we have Q and P lying on the line segment BD. So instead of ABD, I will say ABQ, and instead of CDB, I will say CDP, right? So let's write this down. Therefore, angle ABQ is equal to angle CDP. Why? Because P and Q lie on BD. Let's mark this as 4. Now let's go ahead and prove the two triangles congruent. So in triangle AQB and triangle CPD, what do I have? I have AB is equal to CD. Why? Because they are the opposite sides of parallelogram. We know that opposite sides of parallelogram are parallel and equal. And we will take reference from equation 4. Angle ABQ is equal to angle CDP. I will say from 4. And also what do I have equal? I have BQ and DP equal to each other. I have BQ is equal to DP. This is given. Therefore, triangle AQB is congruent to triangle CPD by side angle side test of congruence. Let's mark this as 5. So what have we proved until so far? This and this. Again you need to prove that AQ is equal to CP. So using these two triangles AQB and CPD, I can say C, A and Q correspond to C and P respectively. I can say that AQ is equal to CP by corresponding pair of congruent triangles. So my fourth part, triangle AQB is congruent to triangle CPD. I will say from 5. Therefore, AQ is equal to CP, corresponding pair of congruent triangles. Let's mark this as 6. Whenever you draw conclusions, just mark the equations. You may or may not need these equations in future, but it's always a good practice to mark so that you can take reference later on. So now the fourth part is also proved. We need to prove that the quadrilateral ABCQ so formed is a parallelogram. So first of all, let's see what we have proved so far. We have proved that AQ is equal to CP. This side is equal to this side, and we have also proved that AP is equal to CQ, right, in your section numbers 2 and 4 respectively. So we have the side opposite sides equal, right, for my quadrilateral APCQ. If I prove any of these sides as parallel, I can say that APCQ is a parallelogram. But let's see if there is an easier way. If you notice over here, draw a bisector, let's say AC. If you draw the bisector AC over here, for quadrilateral ABCD, ABCD is a parallelogram, right? What do we know about parallelograms? That the diagonals bisect each other, correct? That means AO is equal to CO. So let's mark this. How do I mark it? I'll mark it with a star. AO is equal to CO. And also I have BO is equal to DO. Now, AO is equal to CO and BO is equal to DO. If I need to prove that APCQ is a parallelogram, I need to show that AO is equal to CO and QO is equal to PO. So how are we going to prove that? We already have AO is equal to CO. How are we going to prove that PO is equal to CO? If you notice, we have BO is equal to CO and we also have BQ is equal to DP. So if I subtract BQ from BO, I will be left with QO, and also if I subtract DP from DO, I will be left with PO, and we also have BQ is equal to DP. Therefore, obviously QO will be equal to QP. Therefore, the diagonals of quadrilateral APCQ are bisecting each other. Therefore, my quadrilateral APCQ is a parallelogram. So let's go ahead and prove this. I'll say for my fifth part, we need a construction. So I'll say construction. Draw diagonal AC, okay, and let AC and BD intersect at O. Right? Now, in quadrilateral, or let's say in parallelogram ABCD, I have AO is equal to CO and BO is equal to DO. Why? Because, let's write the reason here, because I do not have much space, since diagonals of a parallelogram bisect each other. So this is my reason over here for AO is equal to BO and DO is equal to BO is equal to DO. A is equal to CO and BO is equal to DO. Now we already have AO is equal to CO. We need to prove that QO is equal to PO. Let's see how we do this. Now BO is equal to DO, and let's mark this as 1 or let's mark this as 7, and I have DP is equal to or BP, sorry, BQ is equal to DP. This is given, correct? Let's mark this as 8. So I'll say subtracting 8 from 7, when equals are see, these are equals over here. When equals are subtracted from equals, I have my remainders as equal. What do I get? BO minus BQ is equal to DO minus DP. So BO minus BQ is what? It is QO, and DO minus DP is what? PO. So let's mark this as 9. Therefore, what do we have? Therefore, we have AO is equal to CO and QO is equal to PO. This implies diagonals of quadrilateral APCQ bisect each other. At O. Correct? Therefore, what can I say? That quadrilateral APCQ is a parallelogram. So, therefore, quadrilateral APCQ, are we following the right sequence? Yes, APCQ is a parallelogram. So, with this, we end the sum. Let's take a look at the remaining questions in the next classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.